Trimethylamine N oxide, which is otherwise known as TMAO, is bad for health. And that's what we'll see here. So TMAO negatively impacts the kidney, brain, high blood pressure, heart failure, peripheral vascular disease, and also atherosclerosis. So in today's video, we'll take a deep dive into which factors impact plasma levels of TMAO. Additionally, later in the video, what's my data, as I have 21 tests tracking this important biomarker. But for now, let's take a look at which foods contain TMAO. TMAO is found in fish, and that's what we'll see here. On the y-axis, we've got the concentration of TMAO and its precursor metabolite, TMA or trimethylamine, and I'll have more on that mechanism coming up in just a bit. And on the x-axis, we've got many different fish types. So in terms of where the highest content of TMAO and TMA is found, it's in cod, lobster, and orange roughy. But what about fish types that are commonly consumed by those of us in the longevity community? For example, salmon. Well, we can see that farm-raised salmon is very low for its content of TMAO and TMA. But I wouldn't recommend that anybody consume farm-raised salmon. I'd prefer to get the wild-caught version, where there we can see that it has more TMA plus TMAO relative to farm-raised salmon. When considering that TMAO is found in fish, that would suggest that fish may be associated with some of those adverse health-related outcomes for TMAO that I just showed in the previous slide. So for now, let's take a look at one of those associations and ask the question, is fish intake associated with Alzheimer's disease incident risk? And that's what we'll see here. This is a meta-analysis of 11 studies, and on the y-axis, we've got relative risk for a diagnosis of Alzheimer's disease plotted against fish intake in grams per day. In terms of what's significant, we put up a red line at a hazard ratio of 1. So where the dashed black lines, if they are completely below 1 or completely above 1, we have a significant association. And what we can see is that for both low and high intakes of fish, there was no significant association for fish intake with Alzheimer's disease incident risk. If anything, at intermediate intakes of around 70 grams per day, we can see that the upper bound of that 95% confidence interval, the dashed black line, almost overlaps with that hazard ratio of 1. In other words, it's a close to significant association for a lower Alzheimer's disease incident risk in association with about 70 grams of fish intake per day. But it overlaps with that red line, so it's not a significant association. So from these data, we can see that fish intake is not associated with Alzheimer's disease incident risk. So this would argue against TMAO coming from fish being related to maybe some of those adverse health-related outcomes that I showed on the previous slide. On the other hand, gut bacteria produce trimethylamine, which is what we'll see here. So starting off in the intestine, dietary precursors including betaine, choline, and ergothioneine, but also carnitine and its derived metabolite gamma-butyrobetane, are converted by gut bacterial enzymes into TMA or trimethylamine. TMA then travels through the blood to the liver, where it is converted, actually oxidized by the liver, into trimethylamine N oxide or TMAO. So with that in mind, which foods contain these TMAO precursors? Well, for the first three, carnitine, choline, and betaine, they're found in beef, eggs, and shrimp. And I should say, some of you probably yelling at me, this guy's anti-meat. No, that's not at all what I'm about to go through. I'm going to say actually the opposite. These foods have been unfairly villainized for their potential role in TMAO formation, and I'll show why that's the case in a minute. And that's because, in part, because betaine is also found in non-meat containing foods, including beets. And ergothioneine is found in high abundance in mushrooms. So if the TMAO story being found in blood was as simple as eat less meat, well, what about vegans who are eating no meat but are eating lots of mushrooms and lots of beets? Potentially, that could be converted into TMA and correspondingly TMAO2. So the gut bacteria TMAO story isn't as simple as reducing intake of these specific foods, and we'll see why that's true in a second. For that, we'll take a look at which factors impact gut bacterial trimethylamine production. And a main factor that controls whether or not TMAO is produced is the pH in the gut lumen. So the gut lumen is the inside of the tube that is the intestine. And under normal conditions, it should be acidic, not alkaline. However, when the pH inside of the gut lumen becomes more alkaline, that leads to the growth of pathogenic bacteria, which produce TMA, which is then correspondingly oxidized to TMAO in the liver. Those pathogenic bacteria don't just produce TMA and correspondingly TMAO, they also produce other metabolites that are bad for health, including indoxyl sulfate, IS, and paracresol sulfate, PCS. And I've covered those other metabolites, those other gut bacteria-derived metabolites in videos on the channel, and I'll link to a couple of them in the right corner. So once they're produced inside of the gut lumen, they can then diffuse, as shown here, in between the spaces for epithelial cells, which are normally connected by tight junctions, which would be disrupted in this case, and then they can be found in the blood. Now, the importance of that lumen pH rise being a significant contributor to TMAO production is that fecal pH increases during aging, which is what we'll see here. So on the y-axis, we've got fecal pH, and then we've got three groups. CE is centenarian, older, and then young subjects. And what we can see is that when compared with the young subjects, centenarians had significantly higher fecal pH relative to young. And if we're looking at the actual numbers, the average fecal pH in the centenarians was 8, and it was 7 in the young subjects. Now you could say 8 versus 7, so what? That's not a big pH difference, but pH is a log scale, which means that the pH in the centenarians was 10 times less acidic relative to the younger subjects. So with that in mind, which factors impact lumen pH? Well, a major factor is fecal levels of short-chain fatty acids, or SCFAs. These SCFAs include acetate, propionate, and butyrate, which can be produced by a high-fiber diet, but also exercise training. So if someone is eating a relatively low-fiber diet and lots of meat, we could expect to see high levels of TMAO. Alternatively, if someone is not doing any exercise training, we could expect to see relatively low levels of fecal short-chain fatty acids and correspondingly high levels of TMAO. Now, I should mention there's more to that story. It also involves kidney function and removing TMAO, but a major part of this story is acidification of the gut lumen and limiting the growth of bacteria that can produce TMA in the first place. All right, so now that we've defined how TMAO is produced, what's optimal? Can we put a specific number on plasma levels of TMAO? So that's what we'll see here. This is a meta-analysis of 10 studies that looked at relative risk or risk of death for all causes plotted against plasma levels of TMAO. In terms of what was significant, we put up that red line at a hazard ratio of 1 again. And now, when the shaded blue region is completely above 1 or completely below 1, we have a significant association. And we can see that that's first true at lower levels when TMAO was less than 2 micromolar, as the shaded blue region is completely below that hazard ratio of 1. On the other hand, when TMAO levels reached greater than 4 micromolar, that was significantly associated with an increased all-cause mortality risk. But this is just half of the equation for defining what may be optimal for plasma levels of TMAO. The other side of the equation is how does TMAO change during aging, which is what we'll see here. With plasma levels of TMAO in young, middle-aged, and older MA/O groups. For the young subjects, they were 20 to 27 years old, and for the middle-aged to older, they were 50 to 79 years old. So first, we can see that 2 micromolar value pops up again as the average value found in youth, which then approximately tripled in the middle-aged and older group. So in terms of defining what's optimal for TMAO when putting these two pieces of data together, first, less than 2 micromolar as the target, as that was consistent across both of these studies, but then also avoiding the age-related increase. Now note that TMAO can be tracked. This isn't just a health and longevity news channel, this is also a health optimization channel. So TMAO can be tracked. And with that in mind, I've been using at-home metabolomics with the kit shown here, Iolo's at-home metabolomics kit, which including TMAO has 623 metabolites. So if you want to use this kit yourself, discount link in the video's description. All right, so what's my data? That's what we'll see here. This is plasma levels of TMAO over the past 3 years, from 2023 to 2025. And again, I have 21 tests over this 3-year period. So when I first started tracking in 2023, over 5 tests, average TMAO was 7.3 micromolar. Over 9 tests in 2024, a bit better to 6 micromolar, average 6 micromolar. And then after the first 7 tests, I'm waiting on test results for test number 8. After the first 7 tests in 2025, average TMAO is 4.6 micromolar. All right, so how can we put this into the context of what's optimal? Well, half of that equation was avoiding the age-related increase. So for at least this 3-year period, this is good news. But the other side of the what's optimal is less than 2 micromolar. And unfortunately, with average values for all 3 of these years, that's a fail. I haven't been able to do that yet. But there's good news, potentially good news in this story, where I may have discovered what the recipe is for helping to keep it low in my case. As we can see that I've been able to achieve relatively low levels of TMAO below that 2 micromolar target for at least 2 of these 21 tests. And note that for 2 additional recent tests, it was a bit closer to 4 micromolar, on the right track towards getting it to less than 2 micromolar. But is this random variability just random test-to-test variability, or am I doing something? So with that in mind, how can I further reduce and keep it below that 2 micromolar target? How can I reduce plasma levels of TMAO? So for now, we're going to take a look at correlations between diet with plasma levels of TMAO. And for those who may be unfamiliar, I've weighed almost all of my food with a food scale since 2015. So for the past 10 years, probably 99% or more, all of it with a food scale. I then take that data, enter it into a diet tracking app, Chronometer, and if you want to use Chronometer yourself, there's a discount link in the video's description. I then pull the Chronometer data into a spreadsheet. So now each test has an average dietary intake that is lined up together. So with enough tests, because I have tracked dietary intake, I can look at correlations. And that's what we're going to see here with the top portion of the correlations for diet versus TMAO as shown there. And note that if you want to see the full correlation list, I have a specific tier on Patreon, a correlations tier, that doesn't just include correlations for diet with TMAO, but all of those 623 metabolomic metabolites, but then also 25 to 30 standard clinical chemistry biomarkers that I test 8 times per year. So if you're interested in that, check it out. All right, so on this list, we've got the lowercase r, which is the correlation coefficient. And then to the right, we've got the p-value, where I've used less than 0.05, nominally significant, as the significance threshold. In terms of what's significant, and atop the list, we see garlic, and there's a negative correlation there. So what that means is, or what that suggests is, that relatively higher intakes of garlic, in my case, the recipe may be different for others, I'd encourage tracking your own data to try to discover your own personalized recipe. Relatively higher intakes of garlic are significantly correlated with lower levels of TMAO. Now note that I said correlation. I am not at all implying causation. The only way to test causation is to actually do the experiment, and I'll have more on that in a minute. But garlic isn't the only inverse correlation with TMAO on this list. We can see that there are many others, including zinc, avocado, nutmeg, celery, non-fat yogurt, MUFO or monounsaturated fatty acids, olives, and black pepper. Now, I also don't know which, if any of these, are actually causative. So what I generally try to do is to follow as many on the list as possible with the goal of moving a biomarker in the quote-unquote right direction and away from age-related trends. But note that there are also positive correlations on this table, including banana, dates, and salt. So what that suggests is when intakes of these foods are relatively higher, that's significantly correlated with higher levels of TMAO, and that will be data moving in the wrong direction. All right, so in terms of interventions that I made for test number 22, I decided to follow, or specifically decided to follow, the garlic correlation. But what the table shows isn't how much garlic that I should actually add to try to make a dent on plasma levels of TMAO. So let's take a look at the plot for garlic versus TMAO as shown here, with TMAO on the y-axis and now the average daily garlic intake that corresponds to each one of these blood tests on the x. So first we can see that significant inverse correlation, so higher levels of garlic significantly correlated with lower levels of TMAO. And then if we're going to extrapolate based on that trend line to reach that 2 micromolar target or lower, we can see that I'd have to achieve, or predicted I'd have to achieve, garlic intakes of around my highest intake of 3.5 grams per day. So with that in mind, I aimed higher for test number 22. Test number 21 was taken at the end of October. Test number 22 was taken in December, late December. And there was 60 days in between those tests, and my average garlic intake over that 60-day period was 2.9 grams per day. Now granted, not as high as 3.5 grams per day, but if we take a look at the plot, we can see that I don't have any data within that range, 2.7 to about 3.5 grams of garlic per day. So at worst, it'll help fill in the plot to see if this is a real correlation or not. Now, if 2.9 grams of garlic per day doesn't make a dent on TMAO, its correlation will weaken, other correlations will strengthen, and then I'll continue to follow the top correlations with the goal of keeping TMAO as low as possible and avoiding its age-related increase. Now, I should mention too that for the 7-day period before testing, I actually averaged a lot more garlic, 5.7 grams per day. So whether it takes 60 days of eating 2.9 grams per day or only 7 days of eating close to 6 grams per day, we'll find out for test number 22. In terms of did it work, when I sent that test for analysis, that was for a December 26 test, 2025, and it takes about a month for those results to come in, which are then posted first on Patreon. So if you're interested in that, check it out. If you've ever wondered what's optimal for biomarkers, well, I have a new Patreon tier dedicated specifically to that. It currently includes the 35 biomarkers shown here, more than 2 hours of video content, 52 published references, and these aren't the reference ranges which you can get from any LLM these days. This is what may be optimal based on how each of these biomarkers changes during aging and their associations and/or their associations with all-cause mortality risk in the largest studies that exist. So if you're interested in that, check it out. If you're interested in more about my attempts to biohack aging, check us out on Patreon, where I offer blood test consults and also post at least twice per day in 4 other Patreon tiers. We've also got a whole bunch of discount and affiliate links that you can use to test yourself that help support the channel, including ultralabtest.com, which is where I get the majority of my non-metabolomic tests done, the clearly filtered water filter, which I use every day, at-home metabolomics, as mentioned in the video, oral microbiome composition, and I'm due to test that again coming up very soon, NAD testing with Ginfinity, epigenetic testing with True Diagnostic, at-home blood testing with SciFox Health, which includes GrimAge, the best epigenetic clock of epigenetic clocks, green tea, diet tracking with Chronometer, and if you'd like to support the channel, you can do that with the website Buy Me a Coffee. We've also got merch, including Data is my North Star, which is what I've got on here. Figuring Stuff Out is my drug, and the ConquerAging or Dietary logo, as shown there. Link in the video's description. Thanks for watching. I hope that you enjoyed the video. Have a great day.